Hello.
Good evening, sir.
Yeah, good evening. We'll continue, and now we'll do some questions today for Parabola. Hopefully, that should revise the whole chapter. So this is the first one. If the segment intercepted by the parabola y square is equal to 4ax with the line lx plus my plus n is equal to 0, subtends a right angle at the vertex, then options are al plus n is equal to 0, 4al plus n is equal to 0, 4am plus n is equal to 0, and 4am minus n is equal to 0. Segment intercepted by the parabola with the line. So by that we mean a line like this segment, right?
Yeah.
This segment subtends right angle at the vertex. That means this angle is 90. Something like this. Don't try to find the points. Finding the points is not important or not necessary. You can find it but it will be too much effort, right?
Yeah.
To find the points of intersection, you'll have to solve the line and the parabola, and there are many variables. It will be a quadratic long one. You have to
Yeah.
think of something else.
Like if we take the points to be a(t1 square, comma 2a(t1), and then same.
You take the points like this, then you can think of trying to work with the condition that 90° at the vertex, right?
Yeah.
So you can say slope of this and slope of this would be such that it is -1 product.
Yeah.
So try that. Once again, I'm getting a call. Try
Yeah.
doing that. Okay, so if you check the slopes and all, I think you should get 2 by
T1, T2.
T1 into 2 by T2 should be -1, right?
Yeah.
So you'll get T1, T2 is equal to -4. That is one result that you will get, right?
Yeah.
Then you have to figure out what you can do about this line equation. If you have a line like this, and clearly it cuts the parabola at 2 points. So definitely at1 square comma 2at1 and at2 square comma 2at2 lie on the line, right?
Yeah.
So you can say that a general point at square comma 2at lies on lx plus my plus n is equal to 0. So if you put that in this, you get a quadratic, right, in t. You'll get lat square plus m into 2at plus n is equal to 0, right?
Yeah.
Now this is a quadratic in t and we know there have to be two real roots, right, for it.
Yeah.
T has to be either t1 or t2, both will satisfy, right?
Yeah.
And we already know product of the roots t1, t2 is -4, right?
Yeah.
So product of the roots in this equation is what? It is c by a, so it should be n by al, right?
Yeah.
Is equal to t1, t2 is equal to -4, and then you get the answer. N is equal to -4al, and 4al plus n should be 0, right?
Yeah.
So if you do think of the parametric form and work with that, then the answer comes much faster. There's not much calculation required. It is just getting this condition and then saying that at square comma 2at will fit the line equation, right?
Yeah.
Okay. Let's go to the next one. This is if the normal to y square is equal to 4ax at at square comma 2at meets the parabola again, meets the parabola again at a capital T square comma 2a capital T. Then complete set of values of T, values of T satisfies what equation? The equations are T square is greater than equal to 8. B is T belongs to -infinity to -8 union 8 to infinity. C is -2 is less than equal to T is less than equal to 2. And D is T square is less than 8. So this is normal to a parabola meets the parabola again at another point. So yesterday we discussed the theory for this, right?
Yeah.
The other point would be T2 would be equal to, we said, minus T1 minus 2 by T1, right?
Yeah.
So capital T here must be minus T minus 2 by T, right?
Yeah.
So now from here, can we figure out what is the range of values of capital T, right? We have to figure out the
Yeah.
range of possible values of capital T from here. So you can say that it is minus of T plus 2 by T. And on T plus 2 by T, what can you say about its values? You can do AM, GM here, right?
Yeah.
I mean, T plus 2 by T would always be greater than equal to root over t into 2 by t. So t plus 2 by t is greater than equal to 2 root 2, right?
Yeah.
So t, this is greater than equal to 2 root 2. So this is less than equal to minus 2 root 2. Or correct, right?
Yeah.
So t square is greater than 8, right?
Yeah.
T square is greater than equal to 8 satisfies. Because less than minus 2 root 2 means t square is less greater than 8, right?
Yeah.
The others don't fit. This is not correct. This is not correct. No. You understand?
Yeah.
Okay. Then um, another question on normals. If you say px plus 2y is equal to 1 is normal to y square is equal to 4ax for no value of p, exactly one value of p, one value of p, exactly two values of p, fourth one is exactly three values of p, three values of p. Think about this one. This line is normal to the equation. So now normal to a parabola, we know multiple forms of that equation. We know one equation like this, mx minus 2am minus am cube. We know tx plus y is equal to 2at plus at cube, right?
Yeah.
This is definitely a line equation is given, so we don't have to worry about the point form, right? Where normal at a point. Point is not given.
Yeah.
There is a third form also, which is a square x by x1, that one, right?
Yeah.
So that form is not relevant here. We need a line equation which is normal. So either this or this. So px plus 2y is equal to 1 is normal to this. So you can say that this line must match either this form or this form, right?
Yeah.
Okay. Then what can you say here? Hmm. The normal here, this line, can we find a point that lies on this line? Like parabola is like this. If the line is like this, maybe it is normal here. So can we find a random point on the line? If we find a point on the line, we can put it in this normal equation, right?
Yeah.
Because if this equation is supposed to be same, they are supposed to be matching equations, right?
Yeah.
Why am I thinking of putting a point on the line in this? Because one thing you could do immediately here is just compare coefficients and all, right?
Yeah.
Or you could say that slope of this line is minus p by 2, and you can put minus p by 2 in this, right?
Yeah.
And you will get an equation which will have y, x, p and stuff, right? And it will be a cubic in p,
Yeah.
right? And what you need to say is that how many real roots are there for that cubic, right?
Yeah.
That will tell you how many values of P there will be normals like this, right?
Yeah.
The problem that will happen is that there is unwanted X and Y also in that cubic. So you have to do something about X and Y. If it was a pure cubic just in P and some other numbers, then it's fine. Then we can try and figure it out. But that is not the case because X and Y have not been removed, right?
Yeah.
You understand what I'm saying?
Yeah.
You will get something like this, no? Y is equal to minus P by 2X plus 2AP by 2 plus AP cube by 8. This is definitely a cubic in P, but we can't do anything because first of all, like Y and X are there. No? That is also unknown. It's not just in terms of P and A, right?
Yeah.
So what I'm saying is, can we find a fixed point on this line? And then we can say that that point lies on this line also, which is also normal equation, right?
Yeah.
So if you want a fixed point on this line, the P is annoying. So put X is equal to 0, right? X is equal to 0, Y will be half, right?
Yeah.
0 comma half always satisfies this line, right?
Yeah.
So if this line is a normal, then this line 0 comma half should lie on this line also.
Yeah.
So you will get what? You will get 0 plus half is equal to 280 plus 80 cubed, right?
Yeah.
You have 2at cube plus 4at minus 1 is equal to 0, right?
Yeah.
Now we can say that, okay, if this equation has multiple roots, then we have multiple values for which this line is normal, right?
Yeah.
So if there's a cubic equation, the possibility of real roots are 1 or 3. You can already eliminate third option, right? And you
Yeah.
can eliminate this also because real roots there will be 1 or 3. Because in cubic equations, what happens? It's imaginary roots will occur in pairs, right?
Yeah.
So you can have 3 real roots or 1 real root. That is the option. So 1 and 3 options are gone. So how do we figure out whether it has 1 real root or 3 real roots? This equation, this function, if it is a purely increasing function, it will have only 1 real root, right?
Yeah.
So if it is continuously increasing, it will have only cut the axis once. So you can take the derivative of this expression. It becomes 6a t square plus 4a, right?
Yeah.
You can take 2a common and it is 3t square plus 1, right? Correct.
+2.
Plus 2.
Yeah.
Now 3t square plus 2 is always positive. So the function is either increasing if a is positive or completely decreasing if a is negative, right?
Yeah.
So it can have only one real root, either in increasing or decreasing case, right?
Yeah.
So exactly one value of p will be there for which this will be normal. No multiple roots, only one real root, right?
Yeah.
You can do the same thing with the y is equal to mx, this equation also, but then you have to put 0.5 to remove x and y, right?
Yeah.
Okay, try this one. I will not say anything. Vertex is at 3 comma 2. Vertex is 3 comma 2. Directrix is x minus y plus 1 is equal to 0. Find the equation of the latest rectum.
Will it be something like the lattice rectum will be parallel to the directrix?
Hmm. So it
So
would
like
be x minus y plus k, right?
yeah,
Parallel to this line. Then what else? You can find the distance between vertex and directrix, right?
yeah,
So let's say directrix is like this, x minus y plus 1. So this is obviously parabola is like this, and vertex is midpoint of this latest rectum, and this should be equal, no? This and this,
yeah,
right? Latest rectum
yeah.
line will be like this. So 3 comma 2 to this, what is the distance?
It will be
2 by root 2, I think root 2, right?
yeah 2 by √2.
Root 2 is the distance, and so then from 3 comma 2 you have to go root 2 distance the other side, right?
Yeah,
So 3 comma 2 is this point, you have to go root 2 distance to find the point here. So how do you get this point if I want to find this point at a root 2 distance from this? You will have to go along this, along the slope, along this line, right?
yeah,
So this is parametric form. Try to get the focus point. Or you could also do, if the equation is this, distance of 3 comma 2 from this is also root 2, right?
yeah,
Right, then you will get k directly, right?
yeah,
You can do 3 minus 2 plus k by root 2 is equal to root 2. Square it, you should get 1 plus k whole square by 2 is equal to 2, so 4. So k plus 1 will be either plus minus 2. So k would be 1 or minus 3, right?
yeah,
1 is for this line, minus 3 is for the other line, right?
yeah,
This is your LR, but in case you have to find out the focus, like you should know how to get the focus also. So what you need is slope of this line, right? This line.
yeah,
So x minus y plus 1 slope was plus 1, right?
yeah,
So this line slope is minus 1, right?
yeah,
So tan theta is equal to minus 1. So you can say theta is minus 45, right?
yeah,
And if I want to find out this point, I can say uh, 3 plus r cos theta and 2 plus r sin theta, right?
yeah,
So r is root 2. So it will be 3 plus root 2. Cos minus 45 is 1 by root 2. And this is 2 plus root 2 into minus 1 by root 2, right?
yeah,
So this is 4 comma 1, right?
yeah,
So focus is 4 comma 1. And if you put that in this line, you get k is minus 3 again, right?
yeah,
So that is the other way to do it. You understood, right?
yeah, I did.
Okay. Then the next one is this one. Locus of point of intersection. Point of intersections of normals drawn at endpoints of focal chord of a parabola. Of focal chord of a parabola. y square is equal to 4ax is what? You have to find the locus of point of intersection of normals drawn at the endpoints of a focal chord. So couple of things of theory that we discussed yesterday. If this is a chord and this is a focal chord, right?
Yeah.
We know that T1 will be here, then T2 will be here, and T1, T2 should be -1, right?
Yeah.
This is the fact for a focal chord. Now, if I make a normal here, and if I make a normal here, they will intersect at some point, and that point of intersection also you are supposed to memorize that result. Point of
Yeah.
intersection of normals, let's call it h comma k, will be a t1 square plus t2 square plus t1 t2 plus 1 comma minus a t1 t2 t1 plus t2, right?
It was +2, right?
Oh, plus 2. This is plus 2 here, everything else is fine, right?
Yeah.
So hk, this is the locus that we need, hk. So now I'll use t1 t2 is -1 here. So you will get a t1 square plus t2 square -1 plus 2, so plus 1. And here t1 t2 is -1, so this is plus a t1 plus t2, right?
Yeah.
So h is equal to this and k is equal to this. So now it is very easy to find the locus. You can say h by a -1 is t1 square plus t2 square, and
Yeah.
k by a is this, right?
Yeah.
It is equal to k by a whole square minus 2 t1 t2, which is minus plus 2, right?
Yeah.
So you get k by a whole square plus 2 is equal to h by a minus 1. 1 second, I have to check. Is it my door or your door?
Yeah, I think it's mine.
Yours, okay?
Yeah, I think it's mine.
Okay. Yeah. So you'll get the locus then, right?
Yeah.
So the locus will be put x and y now, and you'll get y square by a square. So y square plus by a square plus 2 is equal to x by a minus 1. So y square plus 2a square is equal to ax minus a. Something like this.
Minus a square.
Ax minus a square. So you get y square is equal to ax minus 3a square.
Yeah.
So y square is equal to ax minus 3a. This is another parabola, is the locus, right?
Yeah.
Okay, then try these two questions. Question 6 is this. Two mutually perpendicular tangents of the parabola y square is equal to 4ax meet its axis in P1 and P2 if S is the focus of the parabola, then find the value of 1 by SP1 plus 1 by SP2. And the second one is this. The latest rectum of a parabola whose focal chord PSQ is such that SP is equal to 3 and SQ is equal to 2 is what? Try these two.
Is the first one 1 by A?
First one is 1 by A. How did you get it?
Because they are perpendicular, so T1, T2 will be -1.
The tangents are perpendicular. Yeah. So yeah, I think slope of tangent is 1 by T. So T1, T2 will be -1. Yeah. Then
And then I just took like 2 points in parametric form,
mhm.
and then with
SP1 and SP2 you're writing.
yeah,
SP1 is distance from focus. So A plus X. So A plus A T1 square. Right?
yeah,
And SP2 is A plus A T2 square. And then you simplify with this T1, T2 is -1. Right?
yeah,
Okay. Then the next one.
yeah. I have to do the next one.
you have several equations, right?
Yeah.
SP, if you take P as this T1 square 2a T1, SP is equal to A plus X. So A plus A T1 square. That is 3, right?
Yeah.
And SQ is equal to A plus A T2 square, and that is 2. Correct?
Yeah.
And we also have that T1, T2 should be -1, right? Because it is a focal chord.
Yeah.
So we have enough equations. We have to find the value of A from here, right?
Yeah.
So, okay. So A, if you divide, we get 1 plus T1 square by 1 plus T2 square is equal to 3 by 2. So you have 2 plus 2T1 square is equal to 3 plus 3T2 square. So 2T1 square is equal to 1 plus 3 by T1 square, right?
Yeah.
You'll get 2T1 power 4 is equal to T1 square plus 3. So equation is 2T1 power 4 minus T1 square minus 3 is equal to 0. This can be factorized. 2T1 power 4 minus 3T1 square plus 2T1 square minus 3 is equal to 0. So T1 square common, 2T1 square minus 3 plus 1, right?
Yeah.
T1 square comes out to be 3 by 2, right?
Yeah.
T1 square comes out to be 3 by 2, then we put it in this and we get A into 1 plus 3 by 2 is equal to 3. So this becomes 2 plus 3, 5 by 2. A is equal to 6 by 5. So latest rectum will be 4 times A,
Yeah.
24 by 5, right?
Yeah.
So this is one way to do it. It is slightly long, but what we can do is we can prove a result here. This is an important, there is an important result. It says that the semi-latus rectum basically means 2A, right?
Yeah.
2A is the harmonic mean of the segments of the focal chord. Segments of the focal chord. So here the focal chord has two segments, 3 and 2, right?
Yeah.
So let's call them B and C. So what is the HM of B and C? It is 2BC by B plus C, right?
Yeah.
So we can say 2BC by B plus C will be equal to 2A. Okay. So now check once what is coming from this result. So you get A is equal to BC by B plus C. So 3 into 2, 6 by 3 plus 2, 5. Right?
Yeah.
And we can prove this. It gives the correct answer. We can prove this also. So what do we need to prove? A plus AT1 square. So what we need to prove is 2A is HM of this. So B, 2A and C are in HP, right?
Yeah.
So 1 by B, 1 by 2A and 1 by C should be in AP, right?
Yeah.
So the result would be 2 times middle term should be equal to sum of the extreme terms, right?
Yeah.
Basically 1 by A should be equal to 1 by B plus 1 by C, right?
Yeah.
And if you remember, you have just now proved in a different question 1 by SP1 plus 1 by SP2 was equal to 1 by A, right?
Yeah.
We did that earlier, you did it, right?
Yeah.
So this is saying the same thing, that if you have a focal chord, the two segments, let's call them B and let's call this C. 1 by B plus 1 by C will always be 1 by A, right?
Yeah.
So that will mean that 1 by B, 1 by 2A and 1 by C are in AP and B, 2A and C are in HP, right?
Yeah.
So you'll be able to write 2A should be equal to 2BC by B plus C. or basically A is equal to BC by B plus C, right?
Yeah.
So if you use that result, the question is solved in an instant. You don't need to do much then, correct?
Yeah.
Otherwise, obviously, you can still solve it, but it is faster. So remember this result. This result is useful. That reciprocal of the focal chord segments adds up to 1 by A.
Yeah.
Write this down somewhere.
Yeah, I did.
Okay. Then the question is, the normal chord of a parabola y square is equal to 4ax at the point whose ordinate is equal to the abscissa equal to the abscissa then angle subtended by the normal chord at the focus. Normal chord at the focus is what? So a little not very well phrased, but uh, the normal chord is basically a chord which is normal to the parabola at one end. Okay.
Yeah.
So first of all, like if I have a parabola, if I draw a normal at this point, this will intersect the parabola again at a point, right? So it is also a chord.
Yeah.
So this is called a normal chord. The normal at one end, and it is a chord, right?
Yeah.
Now, where are we making it? We are making it at the point where ordinate is equal to abscissa. So that means x and y are same, right?
Yeah.
So what will be the x and y same value? It will be x is equal to 4a, right?
Yeah.
So this point will be 4a comma 4a, right?
Yeah.
So basically a t square is 4a, so t is equal to 2. This is the point, right?
Yeah.
If we know t value, we can find the equation of the normal now, right? Equation of the normal would be tx plus y is equal to 2at plus at cube, right?
Yeah.
So t is 2, so therefore it is 2x plus y is equal to 4a plus 8a, so 12a. 2x plus y is equal to 12a, right?
Yeah.
This is my normal equation, and I know this point. Can I also find this point? Yes, because I know the rule that t2 should be this, right?
One. Yeah.
So t was 2, t1 was 2, so minus 2 by 2. So it is minus 3, right?
Yeah.
So I know the second point also, this point. T2 is minus 3, so it is a t square. So 9a comma 2at, so minus 6a, right?
Yeah.
Now what we have to find is what is the angle subtended by this normal chord at the focus, right?
Yeah.
So join it like this, and we need to find this angle, right?
Yeah.
So 4a, what is the slope? 4a minus 0 by 3a, 4 by 3 here. And here the slope is, this is m1, m2 is minus 6a minus 0 by 9a minus a, so 8a. So this is minus 3 by 4,
Four.
right? So the angle is 90, right?
Yeah.
angle subtended will be pi by 2 because we are getting m1, m2 is -1, right?
Yeah.
So this again tells us something. This tells us that, I mean, this is a special case. In this case, angle subtended is 90, right? When normal chord is from the point 4a comma 4a, it meets the parabola again at this point, and then 90-degree angle is coming, right?
Yeah.
Okay. What you should do now is one class we can do where we just discuss JEE questions on this. So from your archives, you have some book, right, for that?
Yeah, I do.
So from that, let's just do parabola JEE questions once. So you will get a sense of what kind of questions are actually coming in the exam. So last 10 years or so, if you try, then we can discuss doubts there and try to see if we have done all the theory that is required for it. Okay.
Yeah.
After that, we'll do ellipse and all. Because once you get a hang of what is happening in parabola, then it's very similar. Everything is almost easily transferable. Like once you do one conic section also properly, you will find it easier the others also. So try this. Tomorrow we'll continue this and we'll hopefully finish this chapter and maybe start ellipse. We'll discuss some JEE questions tomorrow.
Okay.
Okay. That's all for now then. I'll see you.
Thank you.
Bye.